Hi there! In the life cycle of software development, software architecture is one of its most important artifacts that guides the development team in building an application. However, it is also one of the most critical and challenging decision-making that has to be done in the life cycle of software development. In the previous video, pinag-usapan natin ang fundamentals of software architecture and design, defining the definition, functions, and role of software architecture in software development. And in this video, pag-usapan natin some of the important principles and design patterns that can be used in order to address the difficult challenges in software architecture. Let us proceed by identifying some of the difficult challenges in software architecture. Number one is complexity. One of the important functions of software architecture is to simplify the complexity that may exist in the requirements and the architecture itself. As the system progresses, the complexity of the requirements and the software design also increases unless proactive actions are taken. Ang pangalawang challenge is ang ivory tower challenge. Ang ivory tower challenge usually happens kapag mayroong isang software architect na nag-design at nag-develop ng isang software architecture and imposes it to the development team with minimal guidance. This challenge usually happens with the third challenge, the big design upfront challenge, which is usually attributed with waterfall model, where most part of the architect are designed and developed by an architect before the development of an application. Because of the high contribution of the architect to the development of the application, the knowledge and understanding of the development team is also reduced, which leads to the fourth challenge, the disconnection between the architect and the developers. To address these difficult challenges in software architecture, the use of proven principles and design patterns are necessary. Ngayon, pag-usapan naman natin some of the important design principles na magagamit sa software architecture. Sa pag-develop ng technologies sa software development ngayon, marami nang nagawa na design principles, katulad na lang ng SOLID principles sa object-oriented development, which was introduced by Robert C. Martin. Ang SOLID principles is a mnemonic acronym for 5 design principles intended to make software designs more understandable, flexible, and maintainable. Umpisahan natin sa unang prinsipyo, ang Single Responsibility Principle or SRP, also known as Separation of Concerns. This principle states that every module, class, or function in a computer program should have responsibility over a single part of that program's functionality, which it should encapsulate. In my opinion, this principle is one of the most important principles in software development, and it should be the top principle applied in software development. It provides great benefits in software development. It makes the software development more understandable and maintainable. This principle is not only applicable on the programming or architectural aspects of the software, but also applicable in the development processes of the software. Consider the process of segregating the trash into different trash bins, which gives great benefits on the environment and the community by recycling the trash. And that is a good application of the principle, which is the proper separation of concerns. Ang pangalawang principle is ang open-close principle. The principle states that software entities should be open for extension but closed for modification. That is, such an entity can allow its behavior to be extended without modifying its source code. This principle is one of the key principles that allows great flexibility to the software, allowing to adapt new functionality with minimum changes to the existing components. One good example of the principle is the concept used in the electric drill, which allows drill bit to be an extension of it and adapt its functionality. Ang pangatlong principle is ang Liskov substitution principle. The principle states that in a program, if S is a subtype of T, then object of type T may be replaced with object of type S without altering any of the desirable properties of the program. These principles allows effective communication between two or more components when there is a common contract between them, which defines the inputs and outputs, their structure and their constraints. Therefore, given two or more components with the same contract, one should be replaceable with other component with the same contract without altering the correctness of the system. One good example of the principle is the concept used in the extension bit of an electric grid, which uses uniform extension chunks that allows replacement of various types of extension bits. Ang pang-apat na prinsipyo is ang Interface Segregation Principle or ISP. The principle states that no client should be forced to depend on methods it does not use. The principle splits interfaces that are very large into small and more specific ones so that clients will only have to know about the methods that they are interested on. This principle goes hand in hand with the first principle, the single responsibility principle. By breaking down interfaces, we favor composition by separating by roles or responsibilities. As an example of the principle, let us consider a multi-tool hand tool that combines several individual functions in a single unit of a hand tool. The tool is maybe useful during emergencies in camping or travel, but in specific use like in kitchen, it is not efficient. In the kitchen, it is more efficient to use a kitchen knife rather than a multi-tool. Ang panglimang principle is ang Dependency Inversion Principle or DIP. The principle states that high-level modules should not depend on low-level modules, but both should depend on abstractions. Abstractions should not depend on details, but details should depend on abstractions. As an example, let us consider the concept used in the extendable screwdriver. The handle of the screwdriver is not dependent on a specific bit because it allows various types of bits that uses same extension chunks. And that's the 5 SOLID principles. Although they apply to any object-oriented design, they can also form a core philosophy for software development methodologies such as agile development. One of the important functions of software architecture in software development is management of trade-offs. Trade-off is where one thing increases and another must decrease, and this is where the principle of opportunity cost comes in, a situational decision that involves diminishing or losing one quality, quantity, or property of a design in return for gains in other aspects. For example, sa pagpili ng programming language sa isang application, kung pipiliin mo ang C++ as a programming language, you are in favoring the qualities of performance while sacrificing the cross-functionality of the application to other operating platforms. Kung mas preferable ng customer ang cross-functionality ng application to different operating platforms over sa performance ng application, mas preferable na piliin ang cross-functional programming languages such as JavaScript. Another important function of software architecture in software development is making the right decision in the right time. And this is where the principle of last responsible moment comes in. A strategy of not making a premature decision but instead delaying commitment and keeping important and irreversible decisions open until the cost of not making a decision becomes greater than the cost of making a decision. For example, sa pagpili ng framework or methodologies na gagamitin sa software development, it is important to take time and explore more options and get opinions from other stakeholders rather than sticking to one option. In decision making, it is important to identify the last responsible moment. If we decide early, it could cause rework due to wrong decision. And if you decide late, you could miss opportunities as well, which will cause rework. Ngayon naman, pag-usapan natin ang some of the important design patterns na pwede natin gamitin sa software architecture. In software engineering, a design pattern is a general repeatable solutions to a commonly occurring problem in software design. It is a description or template for how to solve a problem that can be used in many different situations. Marami nang nagawa na design patterns for different situations and scenarios. The design patterns can be categorized as follows: creational, structural, behavioral, functional, concurrency, and architectural. For this lecture, we will be focusing on architectural design patterns. Even though an architecture pattern conveys an image of a system, it is not an architecture. An architectural pattern is a concept that solves and delineates some essential cohesive elements of a software architecture. Countless different architectures may implement the same pattern and share the related characteristics. Ibig sabihin, ang isang architectural design pattern ay hindi pwede mag-represent ng entire architecture ng isang application dahil ito ay isang konsepto lamang at ang architecture ng isang application ay pwede gumamit ng one or more architectural design pattern at the same time. Marami nang nagawa na architectural design patterns for software development. Here are some of the most commonly used architectural design patterns available. Umpisahan natin sa client-server na design pattern. This is where you have a server and multiple clients. For example, you have a web server where nagko-connect doon ang different clients. For example, meron kang laptop, meron kang phone, and meron kang PC na nagko-connect sa the same server over internet. Ang design pattern na to ay gumagamit ng solid principles, katulad ng single responsibility principle, open-close principle, at dependency inversion principle. Ang pangalawang design pattern is ang layer design pattern. Ang design pattern na to is ang extension ng naunang design pattern, ang client-server design pattern, where it applies the separation of concern principle. Ang server side ay hinati niya sa dalawa, ang logic tier at data tier, where ang clients is ang representation ng presentation tier. Ang presentation tier ang nagre-represent sa UI ng application. Ang logic tier is ang nagre-represent sa business logic ng application. At ang data tier are usually the representation of the data or database. Ang design pattern na to ay gumagamit din ng solid principles, katulad na lang ng open-close principle, kung saan ang logic tier ay hindi siya dependent sa presentation tier o sa data tier. Ibig sabihin, ang business logic tier ay pwede siya mag-support ng iba't ibang presentation tier or UI at pwede rin siya mag-support ng iba't ibang database with minimal changes sa logic na tier. Ang pangatlong design pattern is ang Model View Controller Design Pattern or MVC design pattern. Ang design pattern na to ay pwede gamiting detail extension sa previous na design patterns, sa layer design patterns, or sa client-server design patterns. Pwede gamitin ang MVC sa presentation tier, logic tier, or pwede rin sa data tier. Ang aim ng design pattern na to is to minimize the change kapag mayroong requirement change. Kapag may babaguhin ka sa UI or sa presentation, doon mo lang babaguhin sa view na script. At kung may babaguhin ka naman sa logic na script, doon mo rin babaguhin sa controller. At kung may magbabago naman sa data, doon mo lang babaguhin sa model. I hope that gives you some insights regarding the important principles and design patterns that can be used in order to address the difficult challenges in software architecture. If you want to know more about the subject matter, check out my notes in the presentation in the description below. And if you have questions or clarifications, please leave us a comment in the comment section below. And do not forget to subscribe and click the notification bell for more videos.